Welcome to session 3 of Polynomials, which is your second chapter of class 9th maths. In this video, let's study about Remainder Theorem. Before studying the Remainder Theorem, just we'll recollect how we have learned to divide two numbers. Suppose we take number 25 is divided by 3. 25 when it is divided by 3. Right? So 3 8s are 24. 1. So 3, 8, 25 and 1 are these four numbers which you know how to relate them. But what is this 3? This 3 is the divisor, 25 is the dividend, 8 is the quotient and 1 is the remainder. So how do we express this? We express this 25 is equal to 3 into 8 plus 1. Right? 3 into 8, 24, 24 plus 1. That means that we have learned that dividend is equal to divisor into quotient plus remainder. This is how we have expressed it, right? This where 25 is equal to 3 into 8 plus 1, 1 is the remainder we have said. Now suppose if we consider another number 12, if it is divided by 6. Now how do we express this? In the same way, 12 is equal to 6 into 2 plus 0. Yes, if you note here, remainder is 0. When the remainder is 0, what you can say that 6 is a multiple of 12, right? So, 6 is a factor of 12 and 12 is a multiple of this 6. Right, like this. Suppose you take like this, you take any other numbers also the same way. Either the number you will find that the remainder is 0 or remainder is something else. Now the question arises is, can we divide two polynomials in the same way? Right? To start with, let's divide a polynomial with another polynomial where the another polynomial is a monomial. Dividing a polynomial by a monomial. We will check what will be the division and how we can express it. Okay. Now suppose we consider a polynomial, for example 4x cube plus 2x square plus x. Polynomial in x. This will be divided by x. Now if you do so, each and every term of this polynomial has to be divided by x. So what it becomes? It is 4x cube divided by x plus 2x square divided by x plus x divided by x. Right? So this leads to 4x square plus 2x plus 1. Right? Now throughout, if you observe, throughout this x is common. Right? So what we can, if you are dividing it, it is leading to 4x square plus 2x plus 1. So this is the result when the polynomial 4x cube plus 2x square plus x is divided by, entire polynomial is divided by x. Right? So this 4x cube plus 2x square plus x can be written as x into 4x square plus 2x plus 1. Right? So these two, x and this one, 4x square plus 2x plus 1 are the factors of this polynomial. Right? Are the factors of this polynomial. Similarly, now if you consider the other polynomial, say another polynomial like 3x cube plus x square plus 1. Okay, and divide this polynomial by x, that is a monomial. Same steps to be followed. So this will lead to 3x cube by x plus x square by x plus 1 by x, if you see. Now this is leading to 3x square plus x, but look at this. If I divide 1 by x, I am not getting any term which is a polynomial. Right? So what I will do is this 3x square plus x plus 1 will be the thing which I am writing That is when you are dividing 1 by x, it is here, right? 1 by x. So completely, if I divide 1 by x, if I take, we are not, when I divide 1 by x, that term which we are getting is not a polynomial term. So how can we write this which is given to us? This one, 3x cube plus x square plus 1. We will write it as x into 3x square plus x, okay, this entire thing plus 1, right? Here we can say that 1 will be the remainder of it, right? Now 1 is the remainder. Like this, if you take any other, now this is what we have learned is dividing a polynomial by another polynomial, that too that polynomial is a monomial, right? Then sometimes it is completely divisible, as we have considered the previous example. Here it was not completely divisible. It is divisible, but here 1 by x, the term which is there, that is not leading to be a polynomial term. Okay, so now let's see what happens if we divide this polynomial by another linear polynomial. This was a monomial, this is also a linear polynomial, right? Now if it is having more than 2 terms, like it is a binomial or so, what will happen, or how this division will be taking place? For that, now let's consider a polynomial p of x equal to, say, 4x cube minus 3x square plus 4x minus 2. This polynomial to be divided by linear polynomial, say x plus 2. Okay, division of a polynomial by another linear polynomial. Before starting the division, let's check whether both of them are in the standard form, that is in their decreasing order of the power, okay, degree. So cube, then square, then x, and then 1, then it is 0. Both of them are in the standard form. So now let's see the division. 4x cube minus 3x square plus 4x minus 2. This will be divided by x plus 2. Now to get the first term of the quotient, what we will do, we will take the highest power of this polynomial p of x, first term of it, that term will be divided by the first term of the divisor. Okay, so the first term of this dividend is 4x cube. That 4x cube, the highest power of the highest power term of the given particular polynomial we are taking. So here it is 4x cube. So if I take 4x cube, that is divided by the first term of the polynomial divisor, x. So what we are getting, it is 4x square. So this 4x square is the first term of the quotient. First term of the quotient will multiply each and every term of the divisor. Okay, then what you are getting, 4x square into x, you are getting 4x cube plus 8x square. Now both the terms here are equal, we have to eliminate them, so we will do subtraction. Okay, so done, this becomes 0. Now minus 3x square minus 8x square gives you minus 11x square. Now bring down this term, 4x minus 2 as it is. Okay, then to get the second term of the second term in the quotient. Now this is the new dividend what we have got, and this is the same divisor. Again, to get the second term of the quotient, what you are going to do is the term which has the highest power in this new dividend, that will be divided by the first term of the divisor. That means minus 11x square will be divided by x. Okay, this leads to what? It leads to minus 11x. So this minus 11x is the second term of the quotient. So again, this second term, that is minus 11x, will be multiplied by each and every term of the divisor. So what you are getting it as minus 11x square minus 22x. same terms. So subtraction we will do, sign will change, right? This becomes plus, okay? Then here it becomes 26x minus 2, right? Now again, just check. It is in the standard form as it is. Again, to get the next term of the quotient, what you are going to do, divide the new dividend's first term, that is 26x, by the first term of the divisor. X gets cancelled, so 26. So plus 26 is the term in the quotient, third term. So multiply it, you get 26x minus plus 52. So both of them are 26x and 26x, they need to be cancelled. So subtraction, so when you are doing subtraction, sign will change. So this becomes 0 and this is becoming minus 54. Correct? So minus 54 is the remainder. 4x square minus 11x plus 26 is the quotient. This is the divisor, x plus 2, and as you know, this p of x is the dividend. Correct? So this is how you divide a polynomial with a linear polynomial. Okay, a polynomial is divided by a linear polynomial. Fine. This is the long division method. Now, just focus on this divisor, x plus 2. This is also a polynomial. Now let's try to find the 0 of this polynomial, x plus 2. To find the 0 of the polynomial, as we have done in the previous exercise, we equate the polynomial to 0. Correct? Then x is equal to minus 2. So x equal to minus 2 is the 0 of this polynomial, x plus 2. Fine. Now x is equal to minus 2 is there, no? This value, let's substitute in this p of x and see. Okay, what is our p of x? Our p of x is equal to 4x cube minus 3x square plus 4x minus 2. Right? For this, let's find out what is p of minus 2. So it becomes 4 minus 2 whole cube minus 3 into minus 2 whole square plus 4 into minus 2 minus 2. Right? So this is 4 into minus 8, then minus 3 into 4 plus 4 into minus 2 minus 2. Correct? Now this is minus 32, minus 12, minus 8, minus 2. How much it is coming to be? If you look at, it is minus 54. Minus 54. Just see. Here the remainder is also minus 54. This is also here when you are finding the value of x at minus 2, then also you are getting minus 54. Keep this in mind. Let's see another example and then we will conclude something about this relation. Is it okay? Now let's consider a second example. Now let's consider another polynomial. Say p of y is equal to 3y raised to 4 minus 8y cube minus y square minus 5y, okay, minus 5 to be divided by say y minus 3. Okay, let's divide this in the same process as we have done. Okay, first check whether they are in the standard form. Both of them are in the standard form. Now we will start the division. That is 3y raised to 4 minus, let me write at this side, 3y raised to 4 minus 8y cube minus y square 5y. This will be divided by y minus 3. So to get the first term in the quotient, this 3y raised to 4 is divided by y. So you get it as 3y cube. Correct? 3y cube. So each term if you multiply, it is 3y raised to 4 minus 9y cube. Do the subtraction. Both of them are the same numbers here, 3y raised to 4 and 3y raised to 4. So subtraction, when you do, the sign will change. So this becomes 0 here, and here it is y cube. The remaining terms bring down as it is. Okay, now y cube it is, y cube. Okay, then to get the second term of the quotient, second term in the quotient, again this y cube will be divided by y. Y cube divided by y gives you y square, so it is plus y square there. Then each term of the quotient, this is the second term of the quotient, will be divided by each term of this divisor. Okay, so y square into y gives you y cube, then minus 3y square, then subtraction, so sign changes, so here it becomes 2y square, correct. Then bring the other terms down, 5y minus 5. Right, next 2y square, here it is the highest power there. Again, to get the next term in the quotient, this 2y square will be divided by y. So if you divide it, you are getting plus 2y, correct. Now each term multiply it by 2y. So if you are multiplying, you are getting 2y square minus 6y. Okay, then again subtraction, so subtraction done, sign will change, then this becomes 0, here it is y, this minus y, bring it down as it is. Then now this you might be thinking, till where we will continue the division? Just check, the degree of the remainder will be lesser than the degree of the divisor. Till then you have to continue. Now if you look at this step, the degree of this remainder is 1, degree of this divisor is also 1, so the division continues. Okay, when can we stop? When this remainder's degree will be less than that of the divisor, then we will stop the division. Now since here it is same, one more step of division will go. So what is the next term in the quotient we will get? Y divided by y is 1. So the next term is 1 in the quotient. So it becomes y minus 3. Y minus 3. When you do the subtraction, you get minus 2. Correct. Now minus 2 is the remainder. So we have concluded that when we are dividing this polynomial by y minus 3, the remainder is minus 2. Okay, that means you can say that this y minus 3 is not a factor of this one. If it is a factor, then it should be completely divisible and the remainder should be 0. Since here remainder is not 0, we can conclude it that way. Okay, this is minus 2 we have got. To get the remainder minus 2, we have done this long division process. Now again, as I said in the previous example, now let's focus on this divisor, y minus 3. Okay, y minus 3, this divisor, let's try to find out the 0 of it. Okay, so to find out the 0 of y minus 3, I am equating it to 0. So y is equal to 3. Now this y equal to 3, I will substitute it here in this equation. Okay, so what is that? P of 3 is equal to 3 into 3 raised to 4 minus, or I'll just do it here. See, keep it in mind that minus 2 is the remainder. I'll substitute here. This is not possible to do there down. So minus, what I said? 3, na? 3 whole raised to 4 minus 8 into 3 raised to 3 minus 3 square minus 5 into 3 minus 5. Okay? If you do so, if you simplify this, what we are getting? 3. This is 3 raised to 4. 3 raised to 4 gives you 81 minus 8. 3 cube is 27 minus 3 square 9. This is 15 and this is 5. Okay. Now if you further simplify, if it is leading to, further simplification is 24, 8 into 27, 216 minus 9 minus 15 minus 5. Okay, so this is 243 minus, this is how much? This is 20, 29 plus 6, 216, 245. So 243 minus 245 gives you minus 2. Right. So remainder is minus 2. Here also it is minus 2. That means what is it? From the two problems what we can generalize is to get the remainder of for a given polynomial, instead of doing this long division way, you can just focus on the divisor, find the 0 of it, substitute that divisor's 0 in the given polynomial, and then the result, the value what you get will be the remainder for that particular problem. Okay, so this we will generalize, put this statement in a form of theorem which is known as the remainder theorem, Okay, we'll state that remainder theorem. So we'll state what is remainder theorem. Remainder theorem. Okay, remainder theorem. Let P of x be a polynomial, be any polynomial of degree greater than or equal to 1. Okay, and let A be any real number. Let A be any real number if P of x is divided by the linear polynomial x minus a. Okay, linear polynomial x minus a, then the remainder is P of a. This is the statement of remainder theorem. Just look up. Let P be any polynomial of degree greater than or equal to 1, and let A be any real number if P of x is divided by linear polynomial x minus a, then the remainder is P of a. Okay, this is the statement of the remainder theorem. Okay, based on this remainder theorem, let's try to solve the exercise questions, which is at 2.3 exercise. Okay, now let's start exercise 2.3. First question in that, what they have said, find the remainder when the polynomial P of x is equal to x cube plus 3x square plus 2, not 2, it is 3x plus 1 is divided by another polynomial. Say that polynomial g of x is x plus 1. You have to find out the remainder of this. Remainder of P of x, that is this polynomial, when it is divided by x plus 1. So now we will not do the long division process for this method. For this we will use the remainder theorem. According to the remainder theorem, what is this? Whatever is the divisor, it's 0 you will find out. Then that 0 you will substitute in P of x, and what value we get, that will be the remainder. So now this g of x is the divisor. So let's find out the solution of this, that is the 0. So to find out the solution, we are equating it into to 0. So x is equal to minus 1. So you will find out the value of P of x at x equal to minus 1. At x equal to minus 1, P of minus 1 is equal to how much? So this is 1 minus 1 whole cube plus 3 into minus 1 whole square plus 3 into minus 1 plus 1. So this cube is minus 1, then again plus 3 minus 3 plus 1. Minus 1 and plus 1 gets cancelled, plus 3 minus 3 gets cancelled, it is 0. Okay, so what it is? 0 is what? 0 is the remainder. Therefore, 0 is the remainder of P of x equal to this one, x cube plus 3x square plus 3x plus 1. Okay. Similarly, for the same polynomial, okay, so for this is right. Now for the same polynomial, you have to find out the 0 where this divisor will be changed. What is the divisor? Next bit they have given you is x minus 1 by 2. This is the first part, first bit. So we will take the second part of it. Okay, P of x is the same. P of x is equal to x cube plus 3x square plus 3x plus 1. Okay, but this g of x is changed. G of x they have given you x minus 1 by 2. So first find out the 0 of this x minus 1 by 2. What will be the 0? X minus 1 by 2 equal to 0 implies x equal to 1 by 2. Okay, now we will substitute this here. We will put it here. P of 1 by 2 is equal to 1 by 2 whole cube plus 3 into 1 by 2 whole square plus 3 into 1 by 2 plus 1. Okay. So this is 1 by 8 plus 3 into 1 by 4, right, plus 3 into 1 by 2 plus 1, right. So 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. We'll put it here. Same thing, we'll substitute, we'll simplify it here. What it is? This is equal to 1 by 8 plus 3 by 4 plus 3 by 2 plus 1 it is, right. Take the LCM of all this. So this is into 2 you will multiply. This is 4 and this one into 8. Correct? So this 8 will be your LCM. 1 plus 6 plus 12 plus 8. 12 plus 8, 20. 20 plus 7, 27 by 8. So what is the remainder? 27 by 8 is the remainder. Therefore, 27 by 8 is the remainder of P of x, which is equal to, what is that P of x? P of x is equal to x cube plus 3x square plus 3x plus 1. Fine. Next, we will see the third bit of it. P of x is the same, but g of x is different. Third part of it. P of x is x cube plus 3x square plus 3x plus 1. Fine. What is g of x? G of x is given as x. What will be the 0 of this one? Equating it to 0, x equal to 0, right? So, find out at x equal to 0, what is P of 0? It is 0 cube plus 3 into 0 square plus 3 into 0 plus 1. So, which is equal to 1. So, what is the remainder? The remainder is 1. Therefore, 1 is the remainder of P of x equal to, what is that? X cube plus 3x square plus 3x plus 1. Okay. We'll see the next one now. Fourth bit of it. First main, fourth bit. What polynomial they have given is P of x equal to x cube plus 3x square plus 3x plus 1, and g of x is equal to x plus pi. Okay, x plus pi. Now 0 of this x plus pi we have to find out. So you will equate x plus pi to 0. So x equal to minus pi. So this x equal to minus pi, you are putting it in p of x. So p of minus pi is equal to minus pi whole cube plus 3 into minus pi whole square plus 3 into minus pi plus 1. So this will be minus pi cube plus 3 pi square minus 3 pi plus 1. So this is the remainder of polynomial p of x. Okay. Therefore, you can write it as minus pi cube plus 3 pi square minus 3 pi plus 1 is the remainder of p of x, which is equal to x cube plus 3x square plus 3x plus 1. Okay. Then we will see the last bit. What it is, fifth question, last bit. They have given you g of x is equal to 5 plus 2x. P of x is the same. G of x is equal to 5 plus 2x. So we will find the solution of this. That is 5 plus 2x is equal to 0. Therefore, x is equal to minus 5 by 2. Right? This x equal to minus 5 by 2, you are going to substitute in p of x. So you are finding out p of x at x equal to minus 1 by 2. At x equal to minus 5 by 2, not 1 by 2, 5 by 2. What is p of x? P of minus 5 by 2 is equal to, here, minus 5 by 2 whole cube plus 3 into minus 5 by 2 whole square plus 3 into minus 5 by 2 plus 1. Right? Now, to simplify that, this implies how much it is? 5 cube. So, minus 125 by 8. This is 5 square is 25. Minus 5 square is 25. 25 into 3 is 75 plus here by 2 square. 2 square is 4 and here minus 3 into 5 is 15. 15 by 2 plus 1. Okay. Now simplify by taking the LCM. This will be into 2. 8 will be the LCM into 4. Right. This is into 8 and 8 here. Correct. Now minus 125. 8 is the LCM. Right. Then 75 into 2, 150. 15 into 4, 60 minus 60 plus 8. If you simplify 25, 150, this will be leading to minus 27 by 8. So this minus 27 by 8 is the remainder when the polynomial p of x is divided by g of x, which is equal to 5 plus 2x. Okay. Now let's move on to the second question. Second one, find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a, they have said. So p of x here is equal to what? X cube minus ax square plus 6x minus a. This will be divided by g of x equal to x minus a. We have to find the remainder. So g of x is x minus a. So first you find the 0 of this polynomial. Okay. So x minus a is equal to 0. Therefore x equal to a. So you are using the remainder theorem. Then so at x equal to a, find out what is p of a. So wherever x is there, you substitute it by a. So this becomes a cube minus a into a whole square plus 6a minus a. Right? So this will be a cube. A into a square is a cube plus 6a minus a. A cube gets cancelled. 6a minus a is equal to 5a. So what is the remainder? Remainder is 5a. Therefore 5a is the remainder. 5a is the remainder when p of x equal to this polynomial x cube minus ax square plus 6x minus a is divided by g of x equal to x minus e. Okay, we'll see the, okay, this is the second question. Now we'll move on to the third one, which is the last question of this exercise. Check whether 7 plus 3x is a factor of 3x cube plus 7x. When a certain number will be a factor of it, factor of p of x, when p of x is completely divisible. That means you can say when the remainder becomes 0, then a polynomial is a factor of another polynomial. So here the first polynomial is this p of x is equal to 3x cube plus 7x. Now you have to check whether this g of x, which is 7 plus 3x, is this a factor of it? That means you have to find out the remainder when 3x cube plus 7x is divided by 7 plus 3x. If the remainder is 0, then yes, g of x is a factor of p of x. Okay, now just find out that. To find out, first we have to find out the zeros of this g of x. Let's see the zeros. 7 plus 3x is equal to 0. So x is equal to what? Minus 7 by 3. Now substituting this one at x equal to minus 7 by 3. Okay, what is p of x? P of minus 7 by 3 is equal to 3 into minus 7 by 3 whole cube plus 7 into minus 7 by 3. Right? So this will be 3 into minus 7 cube is 343 by 3 cube 27 minus 49 by 3. Simplify this. This is 9. So what it is? Minus 343 by 9 minus 49 by 3. Okay. Now you take the LCM of this one. What will be the LCM? This is into 3 I will take, and this is also into 3. So this will lead to minus 343 by 9 minus 27 to 12 14 by 9. 343 minus 343 and minus 147 will give you how much it is? 490 minus 490, right, 490 by 9 minus 490 by 9. Is this equal to 0? No, this is not equal to 0. Therefore, so I'll conclude here. Therefore, what is that? 7 plus 3x is not a factor of x 3x cube plus 7x. Why? Because the remainder is not 0. You can even say like this. Since the remainder is not equal to 0, 7x plus 3 is not a factor of 3x cube plus 7x. Okay, by this we will complete the exercise 2.3, and that's all in today's video. Thank you.